Hi, my dears. Today we'll be discussing on the refraction by spherical lenses. So first we will see the definition of a lens. So lens, as contrast to the mirror, has transparent material on both the surfaces. That is, it's a transparent material bound by two surfaces, of which one or both surfaces are spherical. That is, in the case of a mirror, you had one surface as a highly polished surface, and one was the reflecting surface. It became a reflecting surface because the other surface was a polished surface. But in case of a lens, it is a transparent material which is bound by two transparent surfaces. Okay, one could be a spherical surface, or the other could be a plane, or a lens can have both the surfaces spherical, as one side convex or both sides convex, or either way, one side convex, one side concave, like that. Okay, so double convex lens or simply convex lens is a lens which have the transparent material whose both the surfaces are spherical surfaces that are bulging outside, that is outwards. That is, both the spherical surfaces are convex lens. So it will be thicker in the middle, while see, in this case, it is thicker in the middle, while the aperture M and N, if you look at the edges, it will be thin. So the middle portion is wider, thicker in the middle than at the edges. And the convex lens have this property of converging the light rays, and so it's also known as a converging lenses. Then the double concave lens is the lens where both the two spherical surfaces are curved inwards. So in that case, it will be thicker in the edges, while it's thinner when compared to the middle portion. So middle portion is thinner here, as both the spherical mirrors are concave. And this concave lens will be diverging the light rays. So if you see, the light will appear to come from this particular point. So the refracting light rays will appear to come from the point F, which is the focus of the concave lens. And as this is diverging the light rays after refraction. This is also called as the diverging lens. A lens can either be concave or convex, has two spherical surfaces. So either of the surfaces forms a part of a sphere. See, if you look at this particular picture where you have a convex lens, this one side, that is the M towards this F1 N portion, belongs to a sphere which is towards the right hand side, while MN towards the side of F2 direction will be if you trace a sphere, it will be towards the left hand side. So these two surfaces of the lens forms they forms a part of two different spheres. The centers of this particular sphere. So this one will belong to this particular side, and this one will belong to this particular sphere. So the center of the spheres are called the center of curvature of the lens. That is, if this lens, this is the center of curvature, while in this particular lens, this is the center of curvature. It is often represented as C1, and the left hand side will be the ones that carry that are of prime importance. So we put it as C1, and this is a C2. The center of curvature, we have found the relation at the radius of curvature. That is, the radius of curvature in the case of a spherical mirrors, you found that the relation is the radius of curvature is twice the focal length. So when it comes to lens, we always normally we will represent it as twice 2f1. That is, the O to f1 is the focal length of this lens. So the C1 is actually twice the focal length, twice the F1. And likewise, for this particular lens, it will be the f2 is the focus. So C2 will be twice the f2. Then center of curvature of the lens is the center of the two spherical spheres of which the lens is a part of, and it is usually represented by the letter C, and the center of curvature is normally represented as C1 and C2 in the case of a lens, as it has two spherical surfaces and it belongs to two spherical spheres. So in case of a lens, we normally represent it as 2f1 and 2f2 instead of C1 and C2. The principal axis of lens is the imaginary straight line which is passing through the two centers of curvature, and it will be inclusive of the optical center of the lens also. So the principal axis, it will be having the imaginary point, that is the C1, the center of curvature, the first one, the focal length, the first focus, the optical center, the f2, and also the second center of curvature. So the range will be in, like, you see an imaginary straight line which is passing through both the centers of curvature, and that will be your principal axis of your lens. Optical center of a lens is the central point of the lens, which is the geometrical center of this particular lens, and it's usually represented by the letter O. And a ray of light which is passing through the optical center of the lens will pass without suffering any deviation. We learned when it comes in the topic refraction that for refraction to occur, the light ray will have to fall obliquely. So in this particular portion, there is no refraction, which means that the light ray is falling perpendicular to the curvature of the lens, and that is why the light ray will not get into, will not suffer any deviation. So the any light ray which is passing through the optical center of the lens will not suffer any deviation after refraction, as the light ray will be falling perpendicular to the center of curvature of the lens, perpendicular to the curvature of the lens. And aperture of the lens. Aperture of the lens is nothing but the effective diameter of the circular outline of the sphere of which constitutes the lens. That is in sorry. In this case, Mn will be the aperture. That is the lens MNN, and in this case, this is the aperture. That is this diameter of this particular, the diameter of this lens is nothing but the aperture of the lens. Then in this, like in your syllabus, you will be including only the thin lenses that have the small apertures. That means the lens whose aperture is much less than the radius of the curvature, and also the two two centers of curvatures are usually equidistant from the optical center, which means your C1 and your C1, the distance between C1 and O, and also C2 and O is the same. That is how that is the syllabus for your for this NCERT grade 10. Okay, so in this in your classes, we'll be discussing only only the lenses that are that are thin and have a small aperture. And an activity is mentioned in your textbook where you're asked to hold a convex lens in your hand. You direct it towards the sun, and you focus a light ray from the sun to a sheet of paper, and you obtain a sharp image of the sun on the paper. So you're asked to hold the paper and the lens in the same position for a while, and you're asked to observe the paper and what happened. So, when you hold the convex lens in your hand, the convex lens is a converging lens. So what happens is that you get an image of the sun. So when you get the image of the sun, the light from the sun is the parallel rays of light. Your convex lens is converging this light ray at a sharp, bright spot, and that is nothing but the real image of the sun. So the concentration of that is the real image of the sun that you're catching on the paper will appear like the bright spot. What happens at that particular point is the convergence of the light ray will cause the concentration of the sunlight at that particular point, and a heat is generated, which causes the paper to first the ash, the smoke will come, and then the paper will catch fire and it will burn. Similarly, we saw it in the case of a concave mirror. The same happens when it comes to convex lens. The principal focus of a convex lens. When the light rays that are parallel to the principal axis falls on a convex lens, the rays after the refraction from the lens will converge at a point on the principal axis, and that is called the principal focus of the convex lens. That is, when all these parallel rays, if you see after refraction, the light ray entered into a denser medium. So it will bend towards the normal. What happens according to the curvature, this part will bend towards the side and this part will bend towards this side. So what happens, it will converge at the point F2 here. So, and it forms the focus on the opposite side of the lens after the refraction. In case of a concave lens, the rays that are parallel to the principal axis will fall on the concave lens and it will get diffracted, right? So it will get diverged. Because it is a diverging light ray, what happens is that it appears to come, or these rays after the refraction will appear to diverge from a point on the principal axis, and that is called the principal focus of a concave mirror. Concave lens. So if you see this refracted ray, you extend it, you will get the focus here. That is, it is from this focus you tend to see that the light ray is appearing to diverge from this particular focus in the case of a concave lens. And this point where the refraction, where they appear to diverge from this point on the principal axis, is called the principal focus of the concave lens. So when the light is passed through the opposites, and in the concave lens, remember the focus will be on the same side of the object. Okay. So when the light is passed through the opposite side, so here the light was passing from the left hand side. So if the light is passing from this right hand side, the focus will be on the opposite side, that is in the left hand side. But in this case, if the light is passing from the left and right hand side, then the focus will also be on the same side, that is on the right hand side. So thus a lens will have two principal foci, that is the F1 and F2, right? So these are the two focal points of the focus of in the case of a lens. We get two foci in case of a lens. And the focal length is nothing but the distance between the focus and the optical center. So the distance between F and O, F1 and O will, or in this case, for you, OF1 and OF2 is of the same distance. So that is nothing but the focal length, which is represented by the small letter F. Now, image formation by lenses. Lenses in mirrors, we saw that it was reflecting the light ray, and that was how the images were formed. When it comes to lenses, what happens, the phenomenon that we are observing is the refraction of light. That is, a light when it travels obliquely from one particular medium. That is, say in case of the lens, it is the light from the air to glass, which is of optically denser medium. It will move closer to the normal, and it will change the direction of the path of light. So the lenses will form based on the phenomenon of refraction of light. So when you draw a ray diagram, you can study the nature, the position, and the relative size of the image, which is formed by the lenses. And in order to draw a ray diagram, you will have to have the intersection of at least two refracted rays. And it could either be a ray which is parallel to the principal axis, or it could be a ray which is passing through the principal focus in the case of a convex lens, or a ray which is appearing to meet at the principal focus in the case of a concave lens, or it could be a ray which is passing through the optical center of the lens. So we will see how these rays will behave when it is parallel to the principal axis, or it is it is passing through the optical center, or it is passing through the focus. So in the case of a convex lens, when a ray of light from the object parallel to the principal axis falls parallel to the principal axis, it will, after the refraction, it will pass through the focus on the other side of the lens. In case of a concave lens, a ray of light which is parallel to the principal axis will appear to diverge from the principal focus. That is, from this point will appear to diverge, which is located on the same side of the lens. Okay, that is the difference between the convex and the concave lens. Convex lens will have the focus on the opposite side, while concave lens will have the focus on the same side. And it will, whichever, in both the cases, they will it appear in the case of the convex lens, it will appear, it will be passing through the focus, while in the case of a concave lens, it will appear to diverge from the principal focus. And a light ray which will is passing through the principal focus in the case of a convex lens will, after the refraction, will emerge parallel to the principal axis. See, this light ray passes through the focus of the convex lens, and after refraction, it will be parallel to the principal axis. In the case of a concave lens, also the ray of light that is appearing to meet at the principal focus, or a ray of light which is directed towards the principal focus of a concave lens, will be emerging parallel to the principal axis. So see this light ray, this is actually directed towards the F2. So it is appearing to meet the principal focus, which is F2 in the case of a concave lens. And this light ray, after the refraction, will be emerging parallel to the principal axis. The ray of light which will pass through the optical center of the lens after the refraction will not have any deviation. It will continue in the same path. And we discussed this because it travels through the optical center, which is perpendicular to the lens, the curved surface of the lens. See, this is the curved surface of the lens in case of the convex lens. So the optical the center of the lens will be perpendicular to the curved surface of the lens. And that is why the refraction does not happen for the light ray which is passing through the optical center of the lens. Likewise, even in the concave lens, see the center of this optical center O is perpendicular to the curvature of the curved surface of the lens. So the curved surface is this side, and the concave this side. So what happens is the ray of light will not suffer any deviation and no refraction happens. So the light ray will travel in the straight line path. So from in the next session, we'll be discussing on the ray diagrams by the convex and the concave lenses. Thank you guys for your attention. Bye.